Okay, 6.3. We can see here how they derive the law of cosines, and so they go through an explanation of this. It tells us here about if angle A is acute and if angle A is obtuse, how they're going to do it. So I'm going to let you read through that. If you want to know how they get it, it's by using the distance formula and using a little bit of our trig identities. So they just go through and they prove how they come up with these formulas. But let's move on to part 2 here, where we're solving a side angle side and side triangles. So case 3, we had done the other 2 cases with the law of sines, but now what if they give us 2 sides and the included angle? So let's look here. It says in number 1, example 1 here, it says solve a triangle ABC with A is 15 inches, B is 10 inches, and angle C is 60 degrees. Round each answer to the nearest tenth. All right, so we're going to solve the triangle. So I'm going to set up my little answer box again. I don't know if I left myself enough room there. Scoot that over a little bit. All right, and so they told us side A is 15 inches, side B is 10 inches, and angle C is 60 degrees. All right, well, I don't know an angle and the side across from it, so I cannot use the law of sines. So I'm going to have to use the law of cosines. So let's start then with side C. So we know our formula for side C is C squared equals A squared plus B squared minus 2AB cosine of angle C. And so I'm going to plug in what I know. I'm looking for side C. I know A is 15, B is 10. So I'm going to plug those in both times here. Cosine, and I know angle C is 60 degrees. Alright, so I'm going to work this out. I'm just going to take and plug all that in my calculator. And so C squared equals, I got 175. Take the square root, and so C is equal to the square root of 175, which is approximately, rounded to the nearest tenth, 13.2. So I know side C is 13.2 inches. Now, I need to find my angles. And so it doesn't matter really which one we start with. It's recommended when you're using the law of cosines to always start with what you believe might be your obtuse angle. Because remember, when you use the law of sines, if your angle's obtuse, it's also, you're going to have those 2 triangles. You're going to have the, where you have the acute angle as well as the obtuse angle. So it's recommended that you go ahead and start with the obtuse angle. So we can do that, or we can do angle B. It doesn't matter on this one. So let's go ahead and let's do angle B, because we're going to have to do the obtuse one on the next one. So, all right, so if we're looking for angle B using the law of, well, do I have to use the law of cosines? Do I know a side and the angle opposite of it? I do. So let's go ahead and find angle B that way. So we can switch now to the law of sines. And so remember, we had the formula that sine of angle B over side B equals sine of angle C over side C. Now remember, I'm not a big fan of using information that I just found, but it's not going to matter which way we go. We're going to have to use that 13.2, whether I use the law of sines or I use the law of cosines. So either way, if I miss it, I'm going to miss the next part anyways. So I'm just going to switch over here. I'm going to plug in what we know. So we're looking for we're looking for angle B. We know side B is 10 equals to sine. We know angle C is 60 degrees. And we know side C is 13.2. So we're going to cross multiply and divide. So I've got 13.2 sine of angle B equals 10 times sine of 60 degrees. Divide by that 13.2. And so sine of B equals 10 times sine of 60 degrees all over 13.2. Remember, when we're looking for an angle, we're going to take the inverse. So angle B is equal to the inverse sine of that fraction there. And so let's put that in our calculator and see what it is approximately. All right, now I got 41.00158 degrees. Okay, so it's 41 degrees there. Now, just as a disclaimer, I used, when I did my notes, I did the law of cosines, and I ended up with 40.9 degrees. So they're really super close, okay? So we can go ahead and say this is 41 degrees. And then how are we going to find angle A? Well, we can use the law that we know about of a triangle, that all the degrees have to add to 180. So 180 minus the other two added together. And so we know that angle A is approximately 79 degrees. And we have solved our triangle.